Okay, students, now again let's continue to the other question. So up next is question number 23. It says find the cube root of z is equal to minus 8i. So we are going to now look for a complex number that can multiply itself for 3 times to give z is equal to minus 8i. So in order to find that, what we need to do is, you see, there is a certain formula we derived in our normal class. So that was given by ck is equal to r is the power of 1 over n is a power of theta plus 2k pi over ni, k running from 0 up to n minus 1. So we are going to apply that one in order to know the cube root of this minus 8i. And once we finish solving that, we will try to again solve b. So the equation is already given to us. So using a, we are going to see how we can solve b2. So now look here in the case of this root extraction formula, as I wrote over here, ck is given by, you see, r is a power of 1 over n is a power of theta plus 2k pi over n times I. Here our k runs from 0 up to n minus 1. Basically our n here is 3 because we are looking for cube roots. If you are looking for cube roots, you see n is going to be 3. So if n is 3, and then 3 minus 1 is 2, so our k runs from 0 up to 2. Basically k runs from 0 up to n minus 1. 3 minus 1 makes 2, so we have here, you see, 2 as our last k input. So now count the number of, you see, k values. 1, 2, 3. So this shows you that we do have 3 different complex numbers as, you see, a cube root for minus 8i. For instance, had you been asked to find the square root, you see, this could have been, you see, 2 only, 0 and 1. 0 and 1, because 2 minus 1 is 1. So you do have 2k values. Now let's proceed. Having n 3 and k 0, 1, 2, let's try to find these values, r and theta. R and theta. And how can you find this r? Come here. The real part for this is 0 and the imaginary part is minus 8. So r is obtained by taking the square root of the sum of the reals and the imaginary one. So here is how r is obtained. The square root of, look, 0 squared, because 0 is our real part and the imaginary part is minus 8, so 0 squared plus minus 8 squared, and this makes radical 64, which actually is 8. And how can we find theta? This theta can be obtained from this minus 8i. The real part is 0, the imaginary part is minus 8. So this shows you that our complex number on a complex plane lies totally on the y-axis, on the negative y-axis. And as I tried to explain earlier, you see, as you are measuring the angle starting from the x-axis, you are going to have, you see, a clockwise direction. So as you are moving in clockwise direction, you will finally come across with a 90 degree, because this is negative 8 lying on the y-axis on the complex plane, or along the real axis on the complex plane, the negative part. So theta is minus pi over 2. So everything is now known. R is known, theta is known. So it's a matter of plugging these two values in place of these two. R is known, theta is known. So we can directly substitute. So the equivalent now root extraction formula for this is going to be this one, as you see now, in place of k take 0, so it's going to be like this. C0 is going to come equal to r to the power of 1 over 3. Directly we put in place of n, number 3, is a power of theta is minus pi over 2 plus, in place of k, I'm using 0, pi over 3 times I. Look, student, this is all about when k is 0. You directly substitute 3 in place of n and 0 in place of k and negative pi over 2 in place of theta, nothing else. So simplifying this, you can have this one. Look, here you are having 8, so 8 is the power of 1 over 3 makes 2, because it is 2. That makes 8 when you multiply it 3 times, okay, repeatedly. So 2 comes as it is, then e is a power of, look, this goes to 0, then minus pi over 6 is going to remain. So e is a power of, you see, minus pi over 6i. So according to Euler's formula, this is basically 2 into cosine of negative pi over 6 plus I times sine negative pi over 6. We know that cosine is an even function. So cosine of a negative angle is the same as cosine of a positive angle. So this basically is 30 degree. So cosine 30 is radical 3 over 2. And this is sine negative 30 degree. So this negative can be taken out because sine is an odd function. So it's going to be negative sine 30 degree, which actually is 1 over 2. So as you see, 2 into radical 3 over 2 minus 1 over 2 I can come. So as you are multiplying this, 2 is cancelled by 2, then radical 3 comes, and 2 is cancelled again by 2, minus I is going to come. So you see, students, this is one of, you see, the cube roots for minus 8i. So guys, if you multiply this one 3 times, again and again, believe me, you will obtain minus negative 8i. Now I told you that we have 3 different cube roots. We found the first one making a k to be 0. Now what follows next is when k is 1. Let's see. When k is 1, every other inputs are taken as they are. That is to say, our r value is 8 as we calculated before. Our theta is negative pi over 2. Now k is now changed to be 1. So you simply put 1 here in place of our k here in our formula. So as usual, 8 to the power of 1 over 3 makes 2. And this is e to the power of minus pi over 2 plus 2 pi. Minus pi over 2 plus 2 pi makes what, student? 4 pi minus pi makes 7 pi. 7 pi over, 2 times 2 is 4. 4 times minus 1 is 3 pi. And 3 pi over 6 is going to come, which actually is pi over 2, right? Pi over 2. So 2 times e to the power of pi over 2i can come. And using Euler approach, this is 2 into cosine of pi over 2 plus I times sine pi over 2. You know that cosine 90 degrees is 0 and sine 90 degrees is 1. So this turns to be 2i. So again, students, you can check that this is the other possible cube root of minus 8i. This can simply checked. How can we check that this is right? Simple. You just need to multiply 2i 3 times. 2i times 2i, as you know, makes negative 4. Negative 4 times 2i makes negative 8i. So what we obtain here is right. Now we obtain 2 cube roots. One for k0 and the other for k equals 1. So the remaining is the case where k is 2. When k is 2, have these two as they are. Our values and theta values are taken as they are, but in place of k here in our formula, we are going to put number 2. Let's see what's going to come. Look, for k equals to 2, everything is taken as it is, but here k is, you see, 2. In place of k, we are having 2 here. So this is 4 pi. 2 times 4 pi is 8 pi. 8 pi minus pi is 7 pi. So 7 pi over 2 times 3 makes 6. 7 pi over 6 can come. Remember, students, 7 pi over 6 is what degree? Just multiply this by 180 over pi. It will be 210 degree. 210 degree is lying in the third quadrant. There in the third quadrant, our reference angle is 30 degree. And also, you see, we are having in the third quadrant negative values for cos as well as sine, because it's only tan and it's reciprocal cotangent that can be positive there. So we do have 2 here. So this is cosine 7 pi over 6 plus I sine 7 pi over 6. Basically, the reference angle for 7 pi over 6 is 30 degree. So this will be 2 times negative cos pi over 6 minus I times sine pi over 6. I'm having negatives here because this 7 pi over 6 is lying in the third quadrant. Both cosine and sine trigonometric values are negatives in the third quadrant. This pi over 6 comes because the reference angle for 7 pi over 6 is pi over 6. So you are having here 2 as it is, and we knew that cosine 30 is radical 3 over 2, so you do have minus in front. Minus radical 3 over 2 comes as it is. Sine 30 is 1 over 2, so before it we do have minus, so 1 over 2 I can come. Now 2 cancels 2, again this 2 cancels 2, minus radical 3 minus I is going to come. Now, dear students, we have obtained 3 different complex numbers as you see, cube roots for minus 8i. So this completes our question letter A. Now follows the other one. You see, hence the roots are, as you see, listed here. When you come to B, it says z squared plus 9 into z the power of 5 plus 8, z squared I equals 0. So you are asked to solve this one. So what do you do for this? Look here. Here we are having product of two numbers being 0. So if this happens, either the first, you see, the first expression or the second expression must make 0. So we have two options here. One is to have the first one 0, and the other is to have the second one 0. Whenever either of the two comes 0, the product comes 0. But look here, in the case of this power of 5 plus 8 z squared I, z squared is a common one. So you can take this square as a common out, and then this power of 3 plus 8i can remain. So we have this equated with 0. And when you come to the second case, the case where z squared plus 9 equals 0, look, z squared can be written as it is, but 9 can also be written as negative of 3 squared I squared. We can do like that because I squared is negative 1 according to the concept of I squared. It is minus 1, minus makes plus. You see, so we are on the right track. Look, student, here later I'm going to apply how we can write a square minus b square in terms of, you see, two binomials product. I'm going to apply that one. Now here, z squared times this is equal to 0, so we do have two options here again. One is the case where z is 0, and the other is the case where this one is 0. Look, one is the case where z squared is 0, and the other is the case where z cubed plus 8i equals 0. And the other case is, you see here, b squared minus 3 squared I squared. So consider z as a and 3i as b. A squared minus b squared can be written as a minus b times a plus b. So you can have z minus 3i into z plus 3i equals 0. Now look, student, if the square of a certain complex number makes 0, then it's obvious that, you see, z is 0. Z is 0. That is the only option we have. So one possible root for this is 0. And when you come to the second one, z cubed plus 8i equals 0. So look, move this 8i to the right. It's going to be z cubed equals minus 8i. So in order to find z, you need to calculate the cube root of minus 8i. But this is already done here, student. Here it is. The cube root of z equals minus 8i are these three. One, radical 3 minus 1, the other 2i, and the third one is minus radical 3 minus I. Here they are, see? So for the second one, we can take all these three. And when you come to this one, the minus 3i can be 0 when z is 3i. So 3i can also be, see, one possible solution. And finally, you can take z to be minus 3i, matter of taking 3i to the right, minus 3i. So students, we have these possibilities. One is 0, the other is the case where we can have cube root of minus 8y, and here we have 3i, and finally minus 3i. So proceeding to the next one, look, z is going to be 0, directly taken from this one. Z here is radical 3 minus I, minus radical 3 minus I, z is equal to 3i. All these three are obtained directly from the obtained solution in A. And finally, z equals 3i or z equals minus 3i. So how many solutions we have? 1, 2, 3, 4, 5. So 5 different, you see, solutions can exist for the question letter B.